Factoring polynomials. This is the 5th time I've tried to record the audio on this video. I hope it works. Okay, factoring polynomials. So we've done factoring of monomials, which is what we did last chapter. Now we're going to look at some polynomials. But we're still going to be looking for the greatest common factor of numbers. Okay, so if I have 3x squared y plus 9x y squared, let's ask ourselves, what's the greatest common factor here? Well, the greatest common number is 3. And then the greatest common x is just x, and then I have y, okay, all in common, so 3xy. So I'm going to factor that out. What's left on the inside is x plus 3y after I divide each of those terms by 3xy. Moving on to another example. Suppose we have a squared plus 2ab plus b squared. Okay, something in this form is going to factor in a special way. Same thing with if I change that plus 2ab to a minus 2ab. Okay, so the top one's going to factor into a plus b squared. The bottom one's going to factor into a minus b squared. Okay, so that's a kind of a special form that you should recognize. Very important thing that you should recognize is a squared minus b squared. Okay, this is a difference of squares. So if you see something squared minus something else squared, this is going to factor like so. A plus b times a minus b. The only difference is those signs. So if I take this and kind of expand it, I'll get a minus ab and a positive ab. Those are going to cancel. That's why I end up with just a squared minus b squared. So that's why this can factor in this fashion. If I have a cubed plus b cubed, and let's also take a cubed minus b cubed, there's a special formula that you're going to use here. So we get a plus b, a minus b on the bottom one, and then it's going to be in the form of a squared minus ab plus b squared, and then a squared plus ab plus b squared. Okay, so these are special formulas which you can refer to. They're in your book. You don't have to go back to this video to figure out what they are. They're in your book. Okay, so factoring, a cubic difference of cubes or an addition of cubes, or I should say sum of cubes. Okay, an example here, 6x squared y squared plus 8 cubed y. Okay, this, I'm going to look for the greatest common factor, which would be 2x squared y. If I divide each term by that, I get left over 3y plus 4x. If I do z squared minus 12z plus 36, I recognize that it looks like this, a squared minus 2ab plus b squared, okay? Because my a is going to be z, and my b is going to be 6. 6 squared is 36, and 6 plus 6 is 12, right? So it's just z minus 6 squared. If that had been a positive 12z, then it would have been z plus 6 squared. Okay, I'm going to look at a difference of squares. I have 4h squared minus 81. Okay, so 4h squared is just 2h squared, and then 81 is 9 squared. So I can split this up as 2h plus 9, 2h minus 9. Okay, here I have a sum of cubes. Okay, 8p cubed is the same thing as 2p in parentheses cubed, and 1 is 1 cubed. So I'm going to use this kind of equation that I have here. So it's going to be 2p plus 1 times 4p squared. I've squared that 2p, minus 2p plus 1, right? So it's 2p times p. Now, it kind of looks like this might factor further, okay? It almost looks like it might be in the form of this a squared minus 2ab plus b squared, but it's not. And the reason is because that 2p term should have been 4p if it was factorable. Okay, so if you look at that, the middle term is 2ab, if we look at that. Okay, but 2ab would be 2 times 2p times 1, which would end up as 4p. So we know that this is not factorable. Okay, so we're going to move on to another example from there. P to the fourth minus q to the fourth, that's a difference of squares. So I get p squared minus q squared times p squared plus q squared. Okay, but then I see another difference of cubes, and that's p plus q times p minus q, and then I leave that p squared q squared as it is. Note that an addition of squares cannot be it's not factorable. Okay, so only a difference of squares. All right, another example here, x plus y cubed plus x minus y cubed. Okay, I have just realized that there is a very easy way to factor this. Okay, but I didn't do it that way, so I'm going to show you how I did it. So we have x plus y times x plus y squared, right? And then x minus y times x minus y. So I'm going to expand the x plus y first by using that formula to just do it quickly. And I'm going to expand x minus y squared. Okay, then I'm going to take my x and multiply it to everything. So it's going to be x cubed plus 2x squared y plus xy squared plus xy squared and then continuing on. I'm not just going to say all that. You can read it as I write it. Okay, all I'm doing is I'm taking my x's and my y's and distributing them across everything. Okay, and I end up with a super long polynomial. Now I'm going to tell you in a minute what the super easy way that I didn't realize while I was doing this video to factorize this. Okay, the y cubes are going to cancel. I see that a bunch of other things are going to cancel. I'm just kind of using my finger to kind of trace along. I realize that there's positive 3x y squared, but then there's also negative, so those are going to cancel, and I'm just left with 6xy squared there, and this factors into 2x times x squared plus 3y squared. I think this was an addition of cubes, so it might have been a lot easier to factor that, but that's okay. We didn't do it that way. Anyway, good luck on your homework, and I hope you have a great day.